Well, today we're going to have a look at the night sky in February of 2025. And there's lots to look at. It's a great time of year to do observing. So we're starting here with the view in the afternoon over the Cambridgeshire countryside. And I'm just going to let things run forward. What we're going to do is let the sun head off over towards the west and sink down towards the horizon. As it does so, we'll bring that over now, and we'll start to see that the sky will gradually turn from the normal blue color, beginning with the colors of sunset. We'll get orange and yellow coming into the sky as the sun gets lower down, and we'll bring that to a stop just as the sun has set, just at the moment after it's fully disappeared below the horizon. So there we go. We're going to stop it just about here, and we should start to see the first of our astronomical objects just in the twilight. And this is our last chance really this year to be able to get a good look at the planet Saturn, sat very low on the horizon. This is the sort of view you'd get with an amateur telescope, a 6 or 8-inch reflector. Obviously the labels have been put on by the software. You have to identify the moons yourself. Sorry about that. But it's relatively easy to do. You can use the app to help you. If we zoom in on the planets, then you can see more detail. You can see the pastel shades of the cloud belts of the planets and the very, very thin rings. In a month's time, those rings will be absolutely edge on to us and they will vanish. All we'll see is the round planet and the moons. When I first started doing astronomy, we only knew of the number of big moons of Saturn, the biggest of which was Titan, and it was thought to be the largest moon in the solar system. Actually, when you look at it, it looks this orange color because you're looking at the atmosphere full of smog and organic molecules, and you can't see through to the ground. And that atmosphere makes it look a bit bigger than it truly is as a solid object. So in fact, Ganymede, that orbits Jupiter, is larger. We'll see that in a moment. So we're going to scroll over and let time run forward a bit, pointing up and towards the south. We have a number of bright stars. There's a constellation of Auriga in the middle of the screen there. But if we pull back so that we've got this fisheye lens view of the whole of the sky above us, we can identify some of the main constellations. Andromeda, Pisces there, the fish, Aries, the next one round in the zodiac, Taurus, of course, the bull, Gemini, the twins, then we've got Cancer, the crab, and just rising up over there we have Leo. Not in the zodiac, of course, my favorite constellation of all, which is Orion, and no tour of the night sky is complete really in the northern hemisphere, at least, without Ursa Major and Ursa Minor, the Great Bear and the Little Bear. And that orange line, that's the line of the planets, and you can see that several of the bright objects are close to that. We're going to have a look at those in a few minutes and work our way across the parade of planets. But first, we should start all good tours of the northern hemisphere night sky with the Great Bear, the Big Dipper, the Saucepan Handle, Ursa Major. There he is, laid out on the sky. It's a very large constellation indeed, and there are a lot of interesting objects in it. What we're going to do first is go halfway along the tail and look at the stars Mizar and Alcor, which are a double star pair. Mizar and Alcor orbit round each other. But if we zoom right in, this case we're going to zoom in on Mizar, you will see that the telescope shows us that Mizar itself is double. And if we did that with Alcor, that too would appear double. So this is a double star system. An awful lot of the stars out there are double. Something like 70–80% of star systems have more than one, and our sun is relatively unusual. Also, just next to the tail of the Great Bear, we have the Pinwheel Galaxy. SEA object number 101, 20 million light years away, way outside our galaxy. The photons that were captured in the image here traveling for 20 million years before landing in the camera. It's quite an amazing thought, isn't it? And that's a classic face-on spiral galaxy. If we cross over to the other side of the tail of the Great Bear and just have a look just down here, we can zoom in and find another galaxy. This is the Whirlpool Galaxy. And in this case, again, we have the face-on galaxy, but it's in the process of eating a smaller dwarf galaxy at the top left there that's come too close to it. And there's stars and dust and gas being hurled all over the place by the chaos that the enormous train wreck that's going on there at the moment is causing. So that's the Whirlpool Galaxy, one of the first galaxies to be looked at and identified as having that spiral structure. Over here in the base of the Great Bear, there's a different type of object. This is the Owl Nebula. This is the remains of a sun-like star that's reached the end of its fuel, run out of ability to carry on generating energy by nuclear fusion, and puffed off its outer layers to make a kind of smoke ring in space. Looks a bit like the shape of an owl. Those are called planetary nebulae, but they have nothing really to do with planets. It's just they looked a bit round and blobby in old telescopes. Just above it, we have the Surfboard Galaxy. This one's even further away, 45 million light years. It is a spiral galaxy. It's somewhat edge-on to us, so it's hard to see the spiral structure. And there are a lot of those dark dust lanes carving across through the image there. We'll pull back from the Surfboard Galaxy now and go above the bowl of the Big Dipper. You can find a nice little cluster of galaxies by following a diagonal line and ending up here. This is Bode's Galaxy and its neighbours. There are 3 little neighbours in the picture. You can see one to the right, one at the bottom, and one just left. So Bode's Galaxy, a classic spiral galaxy. It's about 10.5 million light years away. And just next to it, literally a neighbour in space, is the Cigar Galaxy. And this one has had a bit of a near miss with its larger neighbour about 6 million years ago, and it's twisted and distorted it and caused chaos, and it's throwing out huge jets of that red hydrogen gas out from the centre of the galaxy, just all caused by the gravitational disruption of coming too close to its giant neighbour. Now we're going to move from the Great Bear to the Little Bear. This is in the centre of the screen now. There's the stick diagram. And you can see the body of the bear at the bottom and a great long tail. Now, there's always something wrong about this because bears don't have long tails. So one suspects that the person who saw these patterns in the sky and made them up hadn't really studied bears very well. But the tip of the tail of the bear is a very special star from our point of view. It's Polaris, the pole star or the North Star. And it just so happens that at the moment, the Earth's axis is pointing at the pole star. The result of that is that it appears to stay still whilst the whole of the sky rotates around it. We're going to simulate that by running time forward at a very high rate, looking up north, straight up at the North Pole of the sky. And you see that Polaris remains stationary. All the other stars seem to rotate around it. That's, of course, because the Earth is turning the other way underneath, going round once a day. And so we'll let that go back, and I'll run time back to where I was and put it back so that everything's in the correct position before we move on. The other interesting thing about Polaris is that it's a very useful distance marker. It's a special kind of star called a Cepheid variable, which pulsates, and the rate of pulsation is a direct measure of the power output. And if we compare the power output to the perceived brightness that we see, we can work out how far away it is by the standard candle rule. If you double the distance away that a standard candle is, it'll look a quarter as bright. Triple it, a ninth as bright. So we can use Polaris to work out the distance to that particular star. And these stars are fairly rare, but they're common enough that we can find them in all sorts of other places and use them as yardsticks. Now we're going to look at the planet Venus, very bright at the moment. It's at its brightest. Just a crescent lit showing. I was observing it just the other night with a small telescope. We had a little telescope fest out on the lawn of the Northumberland Observatory here in Cambridge. Lots of people brought their scopes along. We had a look at Venus through a small 4-inch telescope. It only looked like a crescent moon, really, but you could see that it wasn't a star. You could see that shape. And you won't see very much more with a larger telescope, because all we're seeing is the cloud tops. The atmosphere of Venus is 100 times as dense as our own and full of clouds, so you don't really see anything down onto the surface. You just see this small crescent shape. The phase changes. It goes as it comes around and overtakes us on the inside, which it's about to do. It gets thinner and thinner and then disappears into the morning sky, and the crescent points the other way. So that's Venus, the second planet of our tour. And the planets lie along that orange line called the ecliptic, roughly, because the solar system is roughly flat. That's the path the sun takes across the sky, and the planets pretty much stick to that. Now, out into deep space again, we're going to look at the constellation of Andromeda, which is that stick line with a line sticking out the side of it. Somehow that was made into a maiden. There she is. She's upside down, but never mind. And she's chained to a rock. This is all part of the legend that things were based on. And really, there are just the 4 main bright stars there in a line. But it's also interesting because it's home to the Andromeda Galaxy, and that's shown here. This is the nearest galaxy to our Milky Way, the nearest main spiral galaxy. It's a little bigger than the Milky Way and 2.5 million light years away, so a lot closer than the other galaxies we've visited so far, and it appears much larger. It's about 5 times as big as the full moon on the sky, best observed with binoculars. A telescope really drills into it too closely. It's got some companion galaxies. This is M32, which orbits around the main galaxy. It's not a star, that's why it looks blurred. And it has another slightly larger companion galaxy, M110, which again orbits around it. Very much easier to see that this is a galaxy, in fact. And of course, we have them, but we have companions that orbit our Milky Way galaxy. We have the large and small Magellanic Clouds that you can see from the southern hemisphere. And we have a number of other small galaxies as well. The third large member of our local group of galaxies is this one. This is the Triangulum galaxy, and it's rather a sort of fluffy galaxy. It has got that spiral arm structure face on to us, but the spiral arms are a bit fluffy and ill-defined. And it's a smaller galaxy. It's about 1/10 the mass of the Milky Way, so rather smaller and a little bit further away, 3 million light years just beyond Andromeda, probably captured by the gravity. All three, the Triangulum galaxy, Andromeda and the Milky Way, will merge in about 5,000 million years time. Going deeper, 27 million light years away, also in Andromeda, this is the Outer Limits galaxy. It is a spiral galaxy, but it's viewed absolutely edge on, and you can see that sort of double fried egg back-to-back arrangement with a bulge in the middle and the spiral arms laid out where the whites would be along the sides, with a big dark dust lane cutting it in two. So that's some of the objects that we can see in and around the constellation of Andromeda. So what we're going to do is pull back now, and then we'll move on and take a look to see what else we can see on our planetary tour. Let's go over here. This is Jupiter. Again, just near that orange line of the ecliptic, a very bright object, high in the sky at the moment. And I looked at this last night, and it looked like this. This is the disk of the planet with the dark dust lanes across it, and the 4 moons laid out. 3 on one side, Io, Europa, and Ganymede, and Callisto off on its own there on the other side, all orbiting round the equatorial plane of the planet. But if we zoom right in, we see a lot more detail. You start to see how intricate the cloud belts are, the north and south polar regions, 1 or 2 white spots, which are large hurricanes in the very fast-moving winds of Jupiter, and some barges, those blue things. But if we move out, the moons turn out to be very, very interesting. This is Io, Looks a bit like a pizza, doesn't it? But it's not made of cheese at all. This is sulfur, and sulfur, if you cool it down at different rates, you get white, black, orange, and yellow, and those are the only colors you see on Io because it is the most volcanic place we know and absolutely turning itself inside out. Just next door, we have Europa, the second large moon of Jupiter. Completely different. This is very shiny and white looking, but covered in grooves and cracks. One or two small craters, but mostly it just looks like sea ice because there is a liquid water ocean underneath a layer of ice there, and it's a prime candidate for finding some sort of alien life forms living in the briny ocean. This is Ganymede, the largest of the moons in the solar system, considerably larger than Io and Europa. And again, we think this has liquid water underneath an ice shell. So another candidate for one of these ice worlds with a liquid water ocean. Very, very interesting from the point of view of astrobiology, the study of alien life. Orbiting further out is Callisto, and this is very different again. This is a dead moon. It's so far away from the gravity of Jupiter, it doesn't get any tidal heating, and it's dead, solid, and covered in craters. So very much the sort of boring one of the four. No doubt I'll be proved wrong about that at some point in the future. But that's in the constellation there of Taurus the Bull. So just above the face of Taurus, you have that very bright object, and that's Jupiter. There's the stick diagram of Taurus. Only the front half of the bull is present. It's got the very large horns, but only two front legs. The hindquarters and back legs are missing. They're actually should be where the constellation of Aries is, but never mind. In the face of the Taurus, the bull, you've got the V shape there with the bright star Aldebaran, an orange giant coming to the end of its life. And then over here, we have the Pleiades, or Seven Sisters, a young star cluster, just 75 million years old. You see 6, 7, 8, maybe bright stars with the naked eye if you've got nice clear skies. But there are about 1,500 altogether. You only see the really powerful, bright ones. The smaller, less massive, fainter ones can be picked up with binoculars or a telescope. And actually, binoculars are the best because this is quite a large object. And the telescope, again, has too narrow a field of view. So if we move over to the tip of the horns of Taurus, we find the Crab Nebula. Messier object number 1. This is an exploded star, a giant star that has blown up, and it was observed in the act of exploding in the year 1054 AD all over the world. The Chinese, Japanese, even the North American original inhabitants saw it and did rock art marking the event. It was so spectacular. So that's the Crab Nebula, and it's still expanding today. We can measure that with our spectrometers and see the rate at which it's expanding and work back, and it all fits with the explosion of a giant star in 1054. So we're now going to move on, and we'll let time run forward to midnight. This brings some of the other things that I want to have a look at into a better position. So the sky is moving around there as the night goes on. Taurus is heading down towards the horizon. And we'll just bring it to a stop there and go and look at the next planet on our tour. This is the planet Mars, very red looking. Again, I looked at this with a collection of small telescopes the other night. It's always disappointing in telescopes because it's so small. I first imagined Mars to be a marvelous thing to look at, but it's always disappointing compared to the giant planets, just because this is half the size of the Earth. So quite a modest planet in its own right. It's got those two moons there, Phobos and Deimos, and it's covered in these red deserts. You can see the red deserts. You can just about make out the dark markings of the highland regions there, and you can usually spot the polar caps. There's one at the top right there. And Mars is very frustrating to observe because it spins in 24 hours and 38 minutes. So if you come back the next night, it's turned right round and shows you the same face again. So it takes a long time before you get to see anything different on the other side, unlike the planet Jupiter, which hurtles round in just 10 hours and changes all the time. So now we're going to have a look down at Orion just before it sets. Orion the Hunter facing off there against Taurus the Bull, an eternal battle in the sky. There he is. And lots of things to see in Orion. It's just next to the Milky Way. There's huge clouds of gas and dust. There's this star here, Betelgeuse. It's a red giant star, and it's due to blow up as a supernova anytime soon. It could be tomorrow, or it could be another million years, perhaps. But it will blow up as a supernova, we think, once it finally runs out of options by way of nuclear fusion. So that's Betelgeuse, the top left-hand corner of Orion. If we go down into the sword handle of Orion, we see the Orion Nebula, one of my favorite objects in the sky of all, an expanding cloud of gas and dust where it's formed new stars. Originally, gravity was winning, pulling material together, making it denser. But once the stars have lit up with their nuclear fusion kicking off, they're blowing a huge bubble and blowing away the rest of the birth cocoon. And that'll make us a star cluster of maybe 1,000 stars once the rest of the gas has been blown away by the strong stellar winds of all those stars. Moving up to the left-hand side of Orion's belt, we've got the star Alnitak. It's a blue giant star, very hot indeed, putting out lots of radiation, lots of ultraviolet radiation, and that is lighting up the gas, causing this red streak here with the finger of dark, dusty material curling in front of it to make the Horsehead Nebula. And then just at the top there, the Flame Nebula as well. Those are well worth trying to go after if you've got really dark skies. They're not as bright as the Orion Nebula, so more difficult to observe. And if we move on again above Orion's belt, we get to another different kind of nebula, another cloud of gas and dust, but here it's glowing blue. And what's happening is that there is a hot young blue star hiding behind the dirty, dusty material that is blocking our view. And the blue light from the star is then bouncing back to us off the cloud of more distant material. That's called a reflection nebula for obvious reasons, and is a relatively uncommon observation, really. And perhaps M78 is the best example if you want to go and have a look at a reflection nebula. So there's loads more to look at in Orion. We could spend the entire show looking at different objects that are in there, but we're going to move on up here to the constellation of Cancer. Now, Cancer has almost no bright stars in it at all. It's very hard to spot. It lies between Gemini on the right and Leo on the left, which is the best way to find it, is to find either one of those two and then work your way in. In the center, there are 4 relatively modest stars making up a sort of quadrilateral. And if we zoom in on that, it's got a lovely star cluster called Prasepe, or the Beehive cluster, right in the middle. A rather older cluster than the Pleiades, so there are no short-lived hot blue stars there. There are only more modest ones in the group, but it makes a nice object to look at with binoculars or a small telescope. So that's the Beehive cluster in the constellation of Cancer the Crab. Again, this is on the zodiac, it's on the ecliptic. The planets do tend to pass through this constellation, and I sometimes even go very close to or in front of that star cluster, which makes a nice shot if you're doing any astrophotography. So we'll pull back a little bit and let's go and have a look at our next target. We'll go back and have a look at Gemini, lying between Taurus and Cancer. Gemini, the heavenly twins. You've got the 2 stars at the top there, Castor and Pollux, and the twins holding hands with their feet at the bottom. And the interloper, the bright red thing, we've already looked at that. That's Mars passing through this zodiac constellation at the moment. There's a couple of nice deep sky objects to go and have a look for. There's the Jellyfish Nebula here, which is a much older supernova remnant, maybe as old as 30,000 years in the past. A star exploded, and we just see the remaining expanding shockwave of blown off material here. Looks a bit like a jellyfish. I can see why they've given it that name. So that's quite nice. There's lots of other objects. You can probably see a few of them in the screen there already. We've got the Monkey Head Nebula down here, and it does look a bit like a monkey head. It's upside down. The top of the head is bottom left, and the mouth is that little divot towards the lower right there, with the neck up at the top. So you've got to spin that round in your mind, and then you might see the monkey head. And again, we've got different colors there. We've got the red from hydrogen, the yellow from helium, and the blue there is blue light bouncing from that star. So that's a little bit of a reflection nebula as well. Another planetary nebula, the remains of a sun-like star, is this one, the Eskimo Nebula. This has undergone a series of eruptions, blowing off these shells of gas from a dying star in the center, and it looks like a little face with a fur hood, hence the name. And that's really quite a nice compact object to try and pin down with a telescope, but it is rather in the middle of nowhere, so you have to get quite good at being able to star hop across some of the fainter stars to get the telescope pointing in the right place. So those are some of the objects in Gemini. Very nicely placed at the moment, very high up, and well worth a look if you get clear skies. So now we're going to move on just to the last part of this little show, and that will be into the pre-dawn sky. You can see the band of the Milky Way there running across, just traversing the bottom end of Gemini. As time goes on, Orion has set, Jupiter's disappeared, Gemini is disappearing now down behind the trees, Mars just about to be going behind that tree and down towards the horizon. But we'll stop there and go and look at the last constellation of the tour, and that is Leo the Lion. Now, this one actually does look like what it's supposed to. I can see a lion and a lion's head and a lion's body when I look at the stick diagram. It's quite rare, really, that they do look like what they're supposed to. So there's Leo, just next door to Cancer and below the feet of the Great Bear. Some interesting objects in here. Again, most of these are galaxies. We've got groups of galaxies. These are named by Charles Messier. So this is M95, 96, and 105 that we have here. And what's happening is we're looking straight out into deep space, out beyond the Milky Way, into areas where there are clusters of galaxies. This one's unusual. It's got a big ring round it, as well as being a spiral galaxy, possibly the result of another collision between a pair of galaxies at some point in the past. When you look at galaxies, you tend to spot that they are mostly these spirals, but here we've got an example of some other forms. There's an elliptical galaxy there, and a more of a lenticular shape one as well. So that not all galaxies are these pure spirals, and the result of galaxy mergers, spiral galaxies bump into each other, merge together, tend to form these large football-shaped ellipticals. Got another group over here. Leo is absolutely festooned with galaxies. This is one of the famous triplets, M66, 65, and one that Charles Messier missed in his catalogue. So it's got an NGC, New General Catalogue Number of 3628. And that one looks like, and is named the Hamburger Galaxy because of its shape. It does look rather like two pates of meat with a gap between them. Gap, of course, that's dust and blocking out the starlight. So quite an unusual looking galaxy. It is probably a spiral, and we're looking straight at the edge of it, edge on. So there's those three galaxies there. So several groups of them. And one of my favorite galaxies of the lot, the Catherine Wheel, NGC 2903. This is a galaxy that's probably similar to the Milky Way in having an elongated nucleus, a a so-called barred spiral galaxy. And then the central part of the galaxy is very orange and red with long-lived, aged stars. All the new stars have died out there. The young stars have gone. No new ones have been formed, whereas the spiral arms tend to have lots of star formation going on, and so we have lots of young blue hot stars that have been newly created but won't be around for long. That tends to be the case in all galaxies. And so with that, I'm going to bring this show to an end, and we'll just spin it round. And I hope you've enjoyed that, and we'll come back next month and have a look at the night sky in March.